check out this video.
Nice. It's HQ.
This is Ace. 1057? Where's the location? Alright, 410. We'll be on our way. Roar Park.
Let's go. I'm Detective Chen. This is Detective Ace.
What do we have here?
We got a call to station last night in 1057 saying that a female, Joanna Jorgensen, was last seen around here at 6 a.m.
Any suspects, leads, evidence?
Not so far, but... Whoa, wait, what? Let you look at this. A phone. I'll take this back to the lab and see what we can do with it.
I want to know everything that's on it.
Yes, sir.
Excuse me. Alright. Alright. We'll be there as fast as we can. Can I talk to you? They caught a perp. He's back at the station. He was last seen biking the same path as Joanna when she disappeared.
What's his name?
Bob.
Got his file.
Bob biking. Any criminal records?
We got him once for jaywalking and public urination, but nothing this big.
Let's go talk to him.
Hungry, Bob?
Yeah.
So was I.
Just gonna ask you a few questions, Bob.
Whoa, I don't even know why I'm here.
Does the name Joanna Jorgensen ring a bell?
Who's Joanna?
Don't act like you don't know who Joanna is.
Witnesses say they saw you on the same path as her last time she disappeared.
Sure, I saw a girl jogging, but I saw a lot of girls jogging.
She was a brunette, 5'4". Sound familiar?
I mean, I guess she sounds familiar, but all I remember was her jogging.
This guy's gonna be tough to crack.
Did the forensics team pull anything out the phone?
Turns out the phone was Joanna's. She was training for a marathon, so she was recording her velocity and time.
Alright, we can use that against him. Let's find this girl. Alright, Bob. We can do this the easy way or the hard way.
Look, I don't know where she is.
I guess it's the hard way. So, Bob, if you remember Joanna running, and you would know her velocity at t = 16.
Who would know that?
You would.
How do I figure that out?
It's simple.
We have to find the acceleration of Joanna when she is 16 minutes into a run. According to this data, we have her velocity at 12 minutes and 20 minutes, but not 16 minutes. In order to find her approximate acceleration at 16, We can take the slope between 12 and 20 minutes, since 16 minutes is exactly in between 12 and 20, and finding the slope will give a fairly accurate estimate. This will give us the average acceleration during this time, which will be 240 minus 200 divided by 20 minus 12, giving us 5 meters per minute squared.
You get it now, Bob?
Yeah, but what does that have to do with anything?
Oh, Bobby.
If you don't know her acceleration, you should at least know her total distance from 0 to 40 minutes.
What?
It's easy. Check this out. To find the total distance of Joanna's travels, we need to take the integral of her velocity from 0 to 40, written as the integral from 0 to 40, absolute value of v of t dt. But since we don't have all of her data, we must use a Wright-Riemann sum using the given intervals to approximate the value.
Well then why is it in an absolute value?
Because, Bob. It's total distance. Keyword total, meaning the distance that Joanna traveled, not the distance from her start point and end point, which doesn't account for the direction traveled or whether or not she backtracked. As I was saying, we would need to find the time that passed between each of her recorded times, which would be 12, 8, 4, 16, and multiply these values accordingly using the values of her velocity at the end of each interval. Thus we would have the absolute value of 12 times 200 plus the absolute value of 8 times 240 plus the absolute value of 4 times negative 220 plus the absolute value of 16 times 150. When we add up those values, we end up with our answer as 7,600. So she traveled 7,600 meters total.
You ready to confess now, Bob?
Look, I don't know any of Joanna's data, but I can tell you mine.
How would you know that?
I always record my velocity. And with that, I could find acceleration. Let me show you. Since acceleration is related to velocity through differentiation, we need to take the derivative of the equation for my velocity to find my acceleration. Since my velocity is modeled by b of t equals t cubed minus 6t squared plus 300 from 0 to 10 minutes, all we have to do is take the derivative of this equation. We can call my acceleration b prime of t, the derivative of my velocity, and by using the power rule, this becomes b prime of t equals 3t squared minus 12t. Now since we want to find my acceleration at time t equals 5, we need to plug in 5 into b prime of t, giving us b prime of 5 equals 3 times 5 squared minus 12 times 5. Simplifying this gives us 75 minus 60, which brings us to our final answer of 15 meters per minute, squared of course since it's acceleration. Duh.
Look at the big brain on Bob.
We don't care about your acceleration at t equals 5.
Well, what about my average velocity?
How would we even find that?
I know a guy. Let's go, Bob.
You sure this is the guy?
That's not Jason.
Bob! Last time I saw you, you peed on my leg at the park. I thought they put you away for good.
I need your help.
I guess. That was my office.
Sit down.
So what do you guys need?
We need Bob's average velocity throughout this bike ride, and you're the only one that can help.
Why should I help you?
Look, you're the only one that could prove me innocent.
Alright, just this once. Don't expect it to happen again! In order to find your average velocity from the start of your ride through 10 minutes of riding, we need to use an equation for average velocity.
Because b of t is a velocity equation, we must use the average value equation rather than the average rate of change, as the average rate of change would give us the average rate of change of your velocity or the average acceleration. The average velocity equation would thus be 1 over 10 minus 0 times the integral of 0 to 10 b of t dt. Using the values of 10 and 0 because they're the endpoints of your time interval that we are looking at. That would then become 1 over 10 times the integral of 0 to 10 t cubed minus 6t squared plus 300 dt.
Oh, cool. So now we could just use a calculator.
No, Bob, we don't have a calculator. We're too poor for that.
Jeez, you didn't have to hit me.
We have to do this by hand and find the antiderivative of the integrand, the equation inside of the integral. Using the power rule for antiderivatives, you then get 1 over 10 bracket t to the 4th power over 4 minus 2t cubed plus 300t end bracket from 0 to 10. Now, plugging in the numbers, you get 1 over 10 to 10 to the 4th over 4 minus 2 times 10 cubed plus 300 times 10 minus 0 to the power of 4 over 4 plus 2 times 0 cubed plus 300 times 0, which would give you a final value of 350 meters per minute. Bob.
Are you thinking what I'm thinking?
What were you thinking?
This has nothing to do with Joanna.
So it's a setup?
Whoa, just take it easy, man.
This has nothing to do with Joanna.
Where is he?
You're stalling, Bob.
Who's stalling? I'm just Bob.
Where is Joanna, Bob?
Who's Joanna Bob?
All this math has nothing to do with finding Joanna.
That has to do with everything! I'm angry!
It's Joanna's fault. Hello?